Hello everyone. This is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous, Visakhapatnam. In this session, I am going to discuss overall explanation of the unit in the examination point of view of Unit 5. Coming to the learning outcomes. After successful completion of this lesson, student will be able to solve the linear equation of second order with variable coefficients by using change of dependent variable when the part of complementary function, that is CF, is known, or to find the complementary function by using inspection method. Solve the linear equation of second order with variable coefficients by using variation of parameters. Solve differential equation by using Cauchy-Euler equation. Solve linear equation by using Legendre's equation. Understand the concept and apply the appropriate methods for solving differential equations. So linear differential equation of order n. This is a linear differential equation of order n. So this is called a linear differential equation of second order with variable coefficients. Linear equation of second order with variable coefficient can be solved by the following methods. Change of dependent variable when the part of complementary function is known, and variation of parameters. Change of dependent variable when the part of complementary function is known. Working rule to solve the linear differential equation with variable coefficients. Reduce the given equations standard form. Either a part of complementary function is given, or it can be found by inspection method. Let it be y is equal to u. Let y is equal to uv be the general solution of equation 1, where v is equal to f of x. Then on differentiating y is equal to e, 2 times we will get these two equations. On substituting these equation in equation 1, it takes the form as this is 1, and after that taking dv by dx is equal to v, and d square v by dx square is equal to dv by dx. In equation 2, we will get this equation, right, which is a linear equation in v and x, v and x, and it can be solved for v. So finally v is equal to dv by dx, and integrating we will get v. Then the required solution is y is equal to uv. Working rule to find the part of complementary function. To find the part of complementary function by the inspection method. These are the complementary function when if we satisfy this is this value, if we satisfy these values, then the complementary function we can take like this directly. Now these are the problems. So this is the first problem. This one divide. This is a differential equation. We have to solve this. So dividing first x square. So then compare this with this equation, linear differential equation. So PQR, then the find out here the complementary function is not given. So using the inspection method, you can find out the complementary function. So this value will be satisfied. That's why here y is equal to x, right, is a part of the complementary function, right? Then after that, here u is equal to, here what is there next to what is a method in this, y is equal to u, so let it be y is equal to u is equal to x. The general solution is y is equal to uv. So after that we have to differentiate this 2 times. Then on substituting these values in equation 1, we will get this, right? Then after that we have to simplify, we will get these equations. Finally, dv by dx is equal to capital V. Then this is a linear equation. We have to compare this with the linear equation. Then P is equal to Q is equal to these values. Then find out the integrating factor. After that, find out the general solution. This is a formula for general solution. Finally, we will get this. Then integrate it. Then we'll get the V value. So after that, after getting V, then write down the general solution of equation 1 is y is equal to uv. Right? Then this is another type of differential equation. So we have to solve this. So here also complementary function is not given. So we have to take find out the complementary function. by using the inspection method. This will be satisfied. So if this function, this value will be satisfied, means this is a part of the complementary function of equation 1, y is equal to e power x. Right? So same method, then find out the general solution is y is equal to uv. From that find out v. Already we have taken e power x. Then only thing is we need to calculate v using the given instructions or even formulas. Then this is the way, same method, d square y by dx square. So then from that substitute all these values, the 2 times differentiate, we will get this is a value. Then after that you have to integrate. So this is a linear equation. Then find out the integrating factor and write down the general solution. Finally we will get this is a value. Then integrate it, we will get the v value. Right? After getting the v, then write down the general solution, y is equal to uv. This is a general solution. Next, coming to the method 2, variation of parameters. These are the working rule for the variation of parameters. Then in order to solve linear equation of second order, we have to proceed two methods. One is if the complementary function is given or known by the inspection method, then apply the method of change of dependent variable. Otherwise, you have to apply the variation of parameters. Right? So here these are the problems on variation of parameters. So for that, first of all, you have to find out the auxiliary equation. From that we'll get the two roots. So according to the roots, we have to write the complementary function. After getting the complementary function, you should write the particular integral. This is a formula for the particular integral. So after that, write down the from the particular integral, write down u and v values and r. Then find out a and b values using the given formula. Before finding a and b values, you need to calculate uv dash minus vu dash value, right? So then find out the ab values. After getting ab, then write down the particular integral. Yp is equal to a cos ax plus b sin ax, right? Then after getting yp, then the solution is y is equal to yc plus yp. This is another formula, another problem in variation of parameters. So same. So first of all, write down in the operator form. Otherwise, directly keep it like this and dividing throughout with the x minus 1, because this is not in the standard form. Then after that, compare this with the PQR general solution, general differential equation. Then use the inspection method. 1 plus P plus Q will we get 0. In the same way, here we will get the two complementary functions. This one also satisfied. Then y is equal to x is another solution of equation 2. So from using these two, we can write down the complementary function. Now after writing the complementary function, then write down the particular integral. This is the formula for the particular integral. Then write down uv and r. Then find out by the method of variation of parameter, write down the value of find out the value of uv dash minus vu dash. So after getting uv dash minus vu dash, then find out the values of a and b. After getting a and b, then write down yp. Then write down the general solution. This is the general solution, yc plus yp. Next, coming to the Cauchy-Euler equation is the third part. In this, we have discussed already variation of parameters. Before that, linear equation, if it's complementary is given, so directly you have to solve the linear equation using the complementary function. Then if it is a complementary function is not given, even then using the inspection method, you can find out the complementary function. They can solve the differential equation. Then after that, variation of parameters. This is the third method, Cauchy-Euler equation. This is the Cauchy-Euler equation. This is the one. And these are the formula. Cauchy-Euler equation can be transformed in a linear equation with constant coefficients. So auxiliary for solving the Cauchy, using the Cauchy-Euler equation, solving the differential equation, we have to find out the auxiliary equation. No? So these are the auxiliary equation. So we have so many, we will get different roots, maybe real and distinct roots, real and equal roots, real and complex roots. If they are real and complex, if they are real and distinct, we have the complementary function from the auxiliary equation. We can write down like this. So clearly explained, and each, if it is a real root, if it is a complex root, one by one, how to write the complementary function from the auxiliary equation. So after getting the auxiliary equation, we'll get the roots. According to the roots, how to write the complementary function I explained here. Now coming to the problems, using the differential equation, write down the Cauchy, apply the Cauchy-Euler equation, Euler form, then we'll get this f of theta. After getting f of theta, write down the auxiliary equation. From the auxiliary equation, we'll get the roots, two roots, because it's a third second degree equation, we'll get the two roots. So from the roots, according to the previous instructions, then we can write down the complementary function. After getting the complementary function, you can write down the particular integral. This one, 1 by f of d into q. Right, q is nothing but here e power z. So here, after getting the e power z, so if it is the denominator, if we substitute e power e, this is in the form of y of 1 by f of d into e power a z. If we substitute a value in this denominator, if we get 0, we should not substitute. Otherwise, we can substitute, we can simplify. So that is only the value of YP. Otherwise, we have different procedures are there we can follow. Already we have discussed in the previous sessions also. So after getting YP, you can write down the general solution. Y is equal to YC plus YP. So this is another second method, another differential equation by using the Cauchy-Euler equation. This is a Cauchy-Euler equation. Using this differential equation, apply Cauchy-Euler equation, we'll get f of theta. After getting f of theta, find out the auxiliary equation. You get the two roots. According to the roots, you can write down the complementary function. Then particular integral, if it is a particular integral like this, it is a product of two functions, e power 2z and sin z. Product of the two functions, then this e power a z, no? So that a value we can add into the theta like this. So the here 3 is also there. Here 3 into theta plus 2 whole square minus 4 into. So simplify that. We will get this is a YP. So finally we will get this is a formula value of YP. 3 into theta plus theta 2 whole square minus 4 into theta plus 2 plus 5. 3 also there. Right, so using that general solution is, this is a general solution by C plus YP, right? So this is another form of the differential equation using Cauchy-Euler Euler equation, Euler form, auxiliary equation. You get the two roots, two equal roots, one is a different root. So from that you can write down the complementary function or particular integral. This is a particular integral already same. Here distribute of this function, distribute one by one. Then after that we can add here e power 0 z. Here if we substitute this, already we discussed in the previous session how to apply this function, how to expand this one the same way. Directly this value we can substitute here because in the denominator will not get 0. So after getting YP, you can write down the general solution. So Legender's equation. This is a form of the Legender's equation. So in this, these are the problems of the Legenders. So convert into the Legender form. We'll get the f of theta. After that, find out the auxiliary equation. So we'll get the repeated roots, so two repeated roots. From that, YC write down by a complementary function. So after getting for complementary function, then write down the particular integral 1 by f of d into q. Q is e power 2z. Okay, same. So same the Cauchy form how we applied, same thing here also you can apply. We can simplify YP. So we will get here what is the formula. This is in the form of 1 by d minus a whole to the power of r. 1 by d minus a whole to the power of r into e power a z. What is the formula? Z to the power of r by r factorial into e power a z. Using that formula you can get the solution, right? So after that we'll get the general solution. This is a second problem in Legenders. So apply the Legenders form. So we'll get the auxiliary equation. After getting the auxiliary equation, we will get the here two distinct real roots. So according to that, you can write down the complementary function. Then after that, particular integral. This is a particular integral format. Here the function is q. Q is nothing but 6x. X is nothing but e power z minus 3 by 2. So simplify that. We'll get the YP is. After that, finally replace theta by 1 and theta by 0. We will get this. Then we can write down the general solution. Y is equal to YC plus YP. With this, I'm going to close. So in this session, we have discussed overall explanation of the unit. The examination point of view of Unit 5. Linear differential equation of order n, working rule the working rule to find the general solution of the differential equation by the method of variation of parameters. Solve the differential equation by using Cauchy-Euler equation. Solve the differential equation by using Legendre's equation. Thank you.